BC Chemistry, Unit 4, Calorimetry, the basic idea. So calorimetry is a word given to the experimental method of measuring the heat energy released or absorbed by a chemical reaction or a physical process, such as by the combustion of fuel or food. So what happens is that the quantity of energy transferred then can be calculated from the increase in temperature of the water in the calorimeter. You'd be like, wait, haven't we already learned that in chapter 2? Actually, we did. We did a lot of transfer of heat calculations in chapter 2, and that's the basic idea of calorimetry. So what happens is that we have a well-insulated container. In this case, it can be made easily from 2 styrofoam cups. It's really, the idea is that it's insulated, so the heat produced by the reaction is not lost through the cup. Then it's filled with water whose temperature change will be measured later. And then a reaction will take place in the cup. So mostly when it's a simple calorimeter like this, it can only be used to measure basically the solutions, the reaction that takes place in the solution. So you put some solutions in and measure the overall volume of water, and then you measure the temperature change of water. So basically any reaction will either release or absorb heat, the resulting in temperature change in water. So it's either increasing temperature or decreasing temperature. And then based on the temperature change of water, we can calculate the amount of heat released by that particular reaction using water's heat capacity. Now, what's water's heat capacity? Do you remember that we used to say like a sample of burning fuel is used to heat up 100 ml of water and calculate the energy in kilojoules that has been transferred if the temperature of water increases from this? It's not a new question. We did that, a lot of that actually in chapter 2. The only difference is that instead of saying burning fuels, we are not burning food. But, well, food is the fuel for your body. So practically they're the same thing, okay? So in order to measure the amount of energy contained in that sample of food, we can burn the food using the heat to heat up 100 ml of water, measure the temperature change in water so as to determine how much heat was released in that burning food. For example, here we use the heat capacity of water, and we know the mass of water is 0.997 times 100 because basically the water density is no longer 1 ml anymore. And then we have the temperature change. So we multiply everything together, we find out the amount of heat that's actually being released in kilojoules, right? It's initially in joules, then we convert it to kilojoules. This then is the heat of the burning food. Of course, you'd be like, okay, in this entire process, there will be a lot of heat that's actually released. Yes, and that will be the complicated part we'll talk about in the next session.